We are looking at enhancing the number hunt project from the YByte Python curriculum available at www.ybyte.in. Previously, we saw how we could use special lists to make these numbers very interesting. For example, we could take list of all even numbers and we could create that list by just doing what is called comprehension, list comprehension. So for example, 2 times x for x in the range 1 to 101. This will give me the list of first 100 even numbers, multiples of 5, all perfect squares, or say all odd numbers. Now, needless to say, if I did not want any of this, it brings me back to my vanilla game. That I did in the class. I could just say numbers equals to x for x in range 1 to 101. That will give me a sequence 1 until 100. Now, these lists we could create using, what is called list comprehension, because they kind of formed a pattern. For some other lists, we may have to do a little bit more work. As we'll see in this video, we will generate a list of prime numbers, because then we can play the game, the entire game over prime numbers. So we'll ask our player to guess the next, let's say the prime number, then find out if it's large or small, and so on and so forth. However, this requires a little bit of work, as we'll see. Let's see how we can create a list of, say, first 100 of us, say 500 prime numbers. This code could be a little bit involved. I'll try to explain every piece of this, but the best method is to try it out, go in small steps and try and understand what's going on. So what I do is that I define a list, called primes in this case, and I just give it one element, 2. Now notice, because I've put this in a square bracket, so this is a list. Also, I've already added 2 in there because, 2 happens to be the smallest prime. Now, the way this code will work is that I'll just keep trying every number from 2, so 2, then 3, then 4, 5, 6, 7, and so on and so forth. And I'm going to use a variable called kk for this purpose. I'll keep doing this while the list of this length is, let's say, less than 100, because I want to get, let's say, first 100 prime numbers. Now, if I want to get 1000, I'm going to make it while list of length, length of prime numbers is, let's say, less than 1000. Now, another way I could write this code is that while, if I want to get prime numbers, let's say until some number, then I'll have to put a while condition on the kk. But here I'm looking at the length of the list, so I make it, let's say, 100. Now, really, what is a prime number? Well, prime number is a number which doesn't have any factors beyond, let's say, itself and 1. So what this means is that in order to find out a prime number, I am just going to have to check if this number is divisible by any other number that is already on the prime numbers list. And if it is divisible, then clearly it's not a prime number. If it's not divisible by any of those numbers, then it's a prime number. So that's what I'm doing. Here I put a for loop. For loop is a repeat loop along with a counter variable. So this for loop runs over this list. So what I'm telling is, hey, look for in primes, which means take every element of the list primes. Find out if this number, which is kk, is a factor of, let's say, rather is divisible by, let's say, And how do I do that? Well, I look at the modulo, which is the remainder. So if the remainder, when I divide kk by is 0, it means that divides kk, which means that kk is clearly not a prime number, and I can then break off. Once I break off, I basically break out of this prime loop and I go to the next kk, which means like I tried 3, then 4, then 5, and so on and so forth. On the other hand, let's say I find that this is not divisible. I go and check my If I have reached the last number of prime numbers list, then this number kk is definitely a prime. I'll talk about this in a moment to explain what's going on. So I say, okay, look, if is equal to primes minus 1. Now this is a little bit, strange perhaps, but this indexing by negative number basically indexes the list from the right side. So primes minus 1 is the last element of the list primes. So what I mean to say here is that, look, I'm checking for this number. I find that this is not divisible by any of the prime numbers that are already on the list. And hence, if I'm at the last prime number, then there's nothing more to divide. This number must be a prime number. And hence, I append this to list prime, which is basically saying add item to this list. And now this list becomes, for example, 2, 3, and so on and so forth. So let's see this code working. It becomes more clear with that. And really, to make our games work over prime numbers, this is really, really pretty much all we need, because remember, we have already set up the game to pick up numbers from a list, and proceed accordingly. So let's see this working. Let's write this piece of code and, make it work, and that makes it more interesting, right? So I come back here to my code. Remember previously I was using numbers as perfect squares. Now I'm going to just override this. I'm going to say, okay, look, numbers is, for example, start with 2, because 2 is the smallest prime number. And I say, okay, look, while, say, len of numbers, numbers is, say, less than 100. Maybe we can start with 10. So while length of numbers is say less than 10, so I want 10 prime numbers, let's say. I'm going to say, I'm going to define, say, kk equals to 2. And I'm just going to try here kk equals to kk plus 1, which is like say, change kk by 1, so kk becomes 3. So having gone to the next number, I just check for whether this number is divisible by any of those prime numbers which are already in this list numbers. So I run a for loop. I say for in say numbers. Um, I want to check if kk is divisible by right? So I say, okay, look, if kk percentage which is fine, that modulo, kk modulo is equal to 0, which means that if I divide kk by if I get a remainder of 0, it means that kk is indeed divisible by and hence it cannot be a prime number. I just need to break from here because no point testing this further. If this is the case, then I just move to the next number because clearly this is not a prime number. On the other hand, let's say kk is not divisible by I need to still be careful because, for example, take 9. 9 is not divisible by 2, but I must check if it's also not divisible by 3. So I must basically, in other words, I must make sure that, I can't declare 9 as a prime just because it's not divisible by 2 because 9 is divisible by 3. So in that note, I just want to make sure that if, let's say, is equal to the last number on this list. So I just going to say numbers, let's say -1. Now numbers -1s means the last element of the list, and we'll see this in action later on. If this is the case, I find that I've reached the last prime number on my list. This number is still not divisible, the number kk is still not divisible by this number, then it must be a prime number, and I'm going to append this to my list. I'm going to say numbers dot append, let's say kk. So append means like adding element to the list, so my list becomes bigger, and next time when I come in, my list has become one longer, I check the next number and so on and so forth. Now just to make this bit more clear, so what I will do is that I'll put some print statements here so that it becomes clear what's going on. So let's just print kk and say numbers, and also let's put numbers -1 over here. So I'm just going to print say numbers -1 just to illustrate how this loop is working. And perhaps instead of getting, let's say, I can get maybe the first 5 prime numbers. So we'll see this in action. So what happens here is that I start with, for example, I start with this list being only 2. I check kk, which is 3. I find that, well, look, kk, which is 3, is not divisible by 2. And also I print numbers -1, which is in this case just 2. So I say, okay, look, I'm done. There's no more number to divide. So I made my numbers, for example, numbers that append 3. So this numbers becomes 2 and 3. So next time when I come into the loop, kk becomes 4. The list is 2 and 3. It turns out 4 is divisible by 2, so I break off, I don't do anything. I come back once again. I look at 5, 2 and 3. I realize that 5 is not divisible by 2, 5 is not divisible by 3, which means I come in here, I print numbers -1. That in this case is 3, because remember, numbers -1 means the last element of this list. So I find that, well, 5 is not divisible by either. I must append this to numbers. So my list becomes 2, 3, 5. I come and check for 6. 6 is divisible by 2. I break out. I come and check for 7. Again, I find out that, well, numbers -1 was 5, which is this. So hence I add 7 into the list. I check 8, I check 9, 10, 11. And finally, I find that 11 is a prime number that I must add. So if I look at, let's say, at this point, if I look at, say, numbers, it has got the first 5 prime numbers. The working is a little bit involved, but I hope it's kind of clear. Now, again, there are many methods of doing this. If you're more comfortable with some other method, that's also perfectly fine. But the bottom line point is that we have now a list of prime numbers, quite nicely done. And now all I need to do is to change my messaging a little bit. I say, okay, look, I've selected the number from the first 100. Instead of perfect squares, I'll say, make it, say, prime numbers. Can you guess? And I can say, look, over here everything remains the same, and when the user makes an imperfect guess, I will go and say, let's say, prime numbers, right? So that it becomes clear. And then I tell my player also to say, okay, please select a prime number from the list of, say, 100 prime numbers. Now, having done this list, I just need to make sure that the number gets picked up from this list. So I just go and say, look, n is now random dot choice. So I just need to go and say n is random dot choice, for example, numbers. In fact, I could have brought this from up here as well, basically because the idea is that the selection of numbers must happen before the n is chosen. And now with this done, I'm going to stop this and run it. Now let's try running this. Obviously, I don't remember all the prime numbers, but I'm referring to the list that I created earlier. So let's try 233. It says smaller than that. Let's try 131. Still smaller than that. I try say 37. Smaller than that, so it's a really small prime number. Let's try 17. Larger than that, so it's between 17 and 37. Let's try just for the fun 28. Right, 28 is not a prime number. Notice our guess is caught. Right, so it says not a prime number, but let's see maybe 29. 29 is smaller than that, so maybe 23. And yes, indeed, it is 23. Now it says you select a prime number for first 100 prime numbers. Click and guess. Let's say we select 251. Right, so that's our number 251. I say, okay, is it 2? No, it's not 2. I say larger than that. Is it 31? Well, larger than that. 73, still larger than that. 127, larger than that. 179, larger than that. 283, now it becomes say smaller than that because my number was 251. I say 239, well, larger than that. 281, smaller than that. 241, larger than that. Smaller than that. 251, that is my number, and it took me 12 attempts to get here. But you get the idea that the same code is now working on prime numbers. Quite interesting. I hope you found this interesting. In general, if you think this way of learning works for you, do look at our website because there are many such activities that will be interesting. Take care. Thank you so much. Bye bye.